Hello everyone, myself PIYUSH and TANDEL, working as Assistant Professor in Electrical Engineering Department of Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. And the name of subject is Industrial Instrumentation, which comes in 4th year, 7th semester. And today we are discussing about the strain gauge and strain measurement, and this is the module number 3. So first of all, starting with flow of content. So in this video lecture, we are going to see the material for strain gauge. Then after, the strain gauge characteristics. So which characteristics strain gauge should have to perform in optimum condition. Then after, wire resistance material. So which kind of material we are going to use for our resistance wire. Followed by the backing material, adhesive, leads and gauging techniques and other factors that are going to affect our measurement. Now, material for strain gauge. The materials that are used for fabrication of strain gauge and their installation for stress measurement must have some characteristics and minimum standard to obtain high accuracy, excellent reproducibility and good sensitivity, long life and ability to operate under required environment conditions. So our instrument or our measuring device should be very much of reliable. It has some good characteristics and minimum standard to obtain high accuracy. So accuracy should be high and excellent reproducibility. The reading should be very good sensitivity, so small amount of change in input output can be sensible. Then after, long life and its ruggedness regarding the environment of the condition. Then after, the strain gauge must have the following characteristics. So strain gauge should have some of the characteristics to perform in good condition, right? So the value of gauge factor G. What is the value of gauge factor? That is must be high. So why we are requiring the value of gauge factor should be high? A high gauge factor indicate a large change in resistance for a particular strain, resulting in high sensitivity. So what is our equation of gauge factor? The equation of gauge factor is delta R by R divided by delta L by L. And what is delta L by L? That is our particular strain. Okay, what is delta L by L? It is our strain. So at low value of strain, the change in resistance should be high. At that time we can call as a large value of or high value of gauge factor, right? So it could have good sensitivity or high sensitivity. Next one, that is the resistance of the strain gauge must be as high as possible to minimize the effect of undesirable variation of resistance in the measurement circuit. So the resistance of the wire should be high to minimize the undesirable variation. So whenever we are measuring some stress with the help of our strain gauge or with the help of our resistance wire strain gauge, the resistance of that wire should be very much of high and it is not vary with respect to different environmental condition. They must have a low resistance temperature coefficient to minimize error on account of temperature variation that affect the accuracy of measurement. So the temperature coefficient should be very good of our resistance strain gauge, because if in our environment our temperature is going to change rapidly, at that time it is going to affect the accuracy of our strain gauge, right? So that's why we must have low resistance temperature coefficient. Then after, the strain gauge must not have any hysteresis effect in response. So we already studied about the hysteresis in first chapter, right? So strain gauge must not have any hysteresis, because if it have some amount of memory for the previous value, then it have some amount of hysteresis effect, and which is going to affect our present value. So we need to minimize that effect. To maintain the consistency of calibration over a complete range, it must have a linear characteristics. So our characteristics should be linear. We also know about the linearity of the instrument, that is the variation in resistance must be a linear function of the strain. They are used for dynamic measurement. Okay, dynamic measurement, it means our value, or we can say our input value, is changing rapidly with respect to time. Hence their frequency response must be good. So rapid change in input should be measured by our instrument. So the frequency response must be very good. The linearity must be maintained within the accuracy limit over a complete frequency of the range. So linearity that must be maintained over a entire range. Okay. So next one, that is the resistance wire material. Now no single material is able to satisfy all the different property. Okay, so we require the composition of different two material or three material to make our cable. Okay, a number of metal or alloy are used to make the resistance wire right now, and some of them are explained, or we can say derived in this table. So over here material, so nichrome, so Ni 80% and Cr, that is 20%, and over here we can see the gauge factor. Over here Ni is the nickel and Cr is from indicating chromium, and atomic weight of the, or atomic number of nichrome is 28 and atomic number of the chromium is 24. So we are mixturing 80% of nichrome and 20% of chromium. So the gauge factor is going to be 2.5. Its resistivity ohm per meter is 100 into 10 raised to minus 8, and temperature coefficient over here and upper limit temperature coefficient here. Then after constant, then after isoelastic, nickel and platinum. So these are different material, for that different gauge factor are going to be indicated, and resistivity is going to be also changed with respect to the material. Okay, so please note this down in your note. Then after we are going to see the backing material. Okay, now the backing material is that part of the strain gauge to which the strain sensitive grid structure is attached. Okay, we are attaching our strain sensitivity structure. Now in addition to the primary electrical installation backing, it helps to retain the geographic shape of the grid pattern to provide protection to the grid. So backing material is going to provide the protection to our resistance wire strain gauge, right? So no damage is going to be there to our cable. So backing material is going to be protect our gauge or protect our resistance wire. The type of backing material used, their temperature range and characteristics are given in table. So there are different types of backing material which we can use in our strain gauge. So starting with the paper, epoxy paper, then after phenolic paper or bakelite, fiberglass, then after transfer glass, glass waves, and so on. Okay, so these are the adhesiveness of different gauge backing material. Then after curing time, its pressure, type, and which temperature range it can handle. So this is also important whenever we are selecting our backing material for the strain gauge. Now next one, that is the adhesiveness. Okay, adhesives, that is what they are the bonding material that are used to fix the strain gauge on the test specimen. Okay, which are used to bonding the strain gauge to the test specimen. Successful bonding depend on correct surface preparation and use of correct bonding agent. So we are connecting our, or we can say we are bonding our resistance wire with the backing material with the help of adhesives. Okay, the bond has to be formed between surface that is to be strained and the plastic backing on which the gauge is mounted. Over here we clearly mentioned that the bond has to be formed between the surface that is to be strained, that is our resistance wire, and the plastic backing on which the gauge is mounted. Improper bonding can be cause many errors like hysteresis, creep, temperature introduce, zero drift. Then after drifting error can be also introduced in our instrumentation, low insulation resistance, etc. Different type of error are going to be there if bonding is not proper between the backing material and the strain material. Okay, it is recommended that the adhesive material must be of quick drying type. Okay, it must be insensitive to moisture and good adherence. Then after, different type of material like cement, chemical reacting cement, and duco cement, different cement are going to be used as a adhesive material to bond two material, that is the strain gauge and backing material. So at the main reason, or you can say main use of adhesiveness is to bonding two different type of materials. Now Next, that is the last one, that is leads. Okay, the leads should be of such material that have low and stable resistivity, because lead is the point from where we are going to take our output of the resistance, right? And low resistance temperature coefficient, because we are putting it into a different environment, so the change in temperature should not affect our leads very much of frequently, right? Now next one, that is the gauge technique and others factor. Okay, the proper operation of the strain gauge depends on the quality to be of bonding that hold the gauge of the surface of structure that undergoes to the test. Okay, whatever the structure undergoes, it is going to depend on the quality of the bonding. Next, that is, if the bond does not transmit the strain from the test piece to the wire or foil of U gauge, the result obtained on the measure can never be accurate, because if the bond is not proper and all the force is acting on the strain gauge is not taken by the resistance wire strain gauge or strain gauge, and only it is going to taken by the backing material, then there are some error, or we can say we are never going to get accurate result. So the force is need to be transmitted to the strain test piece. Okay, the factors on which the operation of strain gauge depends are here. So we are starting with the installation. So first of all, installation. The size of a strain gauge is an important parameter for measurement faithfulness. The drawbacks of gauge size are, first one, that is the gauge size in physical. Okay, the gauge size must be such that it must fit into the available surface of the specimen. So size should be adjustable or minimum size, so it can adjust anywhere in our surface. Then after, the strain gradient at the location where strain is mounted will average output strain below its strain sensitive grade. Now, the wavelength of the vibratory strain must be large as compared to the wavelength or length of the gauge to reduce the error in the dynamic response, because we are changing our input with respect to the time. So, for the good fidelity in the magnitude of strain production, the gauge length must be less than 1/20th of the wavelength of the vibration. So, we are neglecting the error with the help of this type of arrangement. And the large possible size of gauge must be used, as the gauge will have lower hysteresis, creep, or zero drift and large current carrying capacities. So the strain gauge circuit must have high input impedance, because the resistance need to be very high. Okay, and the surface on which the strain gauge is mounted must be very smooth, so there are no error, or we can say all the stress that are applied on the stress test paper or stress state material, it is going to be measured very much of accurately. And all the scales, rust, paint and other surface contamination must be removed from the metal surface. So we frequently need to clean our strain gauge, right? Now talking about the next topic, that is hysteresis. Okay, the bonded strain gauge must sense the same amount of strain as that is experienced by the surface to which it is bonded. So bonded material is also going to experience some amount of force or some amount of stress, which is exactly same amount that is sensed by the strain gauge. And figure, here we have one figure which shows the loop of the cycling loading. So starting with, this is the one, after that it is going to be in negative direction. So over here this is not going to be 0, but at some value point, from that it is going to 3, then after 4, 5, 6 and so on, it is going to be increasing. And this is inside of the micro strain. Okay, this is inside of the micro strain, and over here that is the change in resistance divided by the actual resistance, and this micro strain, that is change in length divided by the actual length, or we can say strain. Okay, if the repeated cycling is done to the strain level higher than the required, then the hysteresis effect will be reduced. A large hysteresis can arise from faulty bonding technique. It cannot be eliminated by cycling. Okay, if there are fault in our bonding, then we cannot eliminate it by cycling, or we can say by number of turns of the input. Now next, that is fatigue life. Okay, Fatigue like failure arises because of stress reversal that occurs at a point where the connecting leads are attached to the strain gauge. So after some time, or we can say after tiring effect, aging of the instrument, the leads are going to connect to from the output side. Okay, we are connecting our measuring device with the leads. So at that point, if there are some amount of stress applied, then we cannot get our accurate result. It can cause decay in the base of gauge or fixing cement, resulting in filament relaxation. For dynamic test, etched foil gauge are preferred over wide gauges. Isoelastic gauge are most convenient in these situations, and the gauge lead must be well secured to prevent relative motion between gauge and leads. They should not have abrupt change in area at that joint. So we already know about the leads, because leads are also important in our strain gauge factor. Next is hysteresis and moisture effect. So the moisture absorbed by the bonding cement or gauge backing cement cause volume change that can elongate or compress our grid. So this is very important term. Whenever the moisture is over there, our bonding cement, or what is our baking cement, or whatever our baking material, that is going to absorb that moisture or humidity, and it is going to change its original shape. It is going to be either increase or decrease in size. So that is going to apply some amount of force to our gauge or gauge grid, and this is what going to introduce some amount of error which we cannot neglect. The humidity effect can be eliminated by bonding the gauge in dry condition, right? And heat is applied through the operation. So humidity can be eliminated by bonding gauge to the drying process and heating process. The defect is observed by the sharp fall in insulation resistance between the gauge and the specimen. Optimum gauge protection method must be adopted. So we require calibration of our gauge by some duration of time, and we cannot neglect the effect of humidity and moisture in our strain gauge measurement. Next, that is creep. For good bonding with the truthful transmission of the strain to the gauge, it is required that the backing material in which the gauge filament is embedded and the bonding cement holding the gauge in position is stronger than the filament. So always we require this type of arrangement. In this condition is not met, then the gauge filament relax under the strain, and the strain indicate it as less than the true strain value. Okay, so we required it to be very much of good bonded, and it is not that much loose or not that much tight. If it is that much amount of loose, then we cannot get the actual amount of strain, and if it is very much of tight, then we are getting higher value than the applied strain, right? So it become a non-linear with increase in the strain. And creep occurs due to the number of sources, that is mainly because of the faulty structure in the gauge itself, faulty bonding, or increase in the temperature. So whenever temperature is going to increase, the gauging effect are there. So the length of the cable is going to be increased, or the material size of the baking material is also going to be changed. So it is going to introduce some amount of creep. The creep is time dependent. It is more than the gauge are initially installed. Okay, creep effect is more significant in smaller gauge because the smaller bonding area. So smaller our size of the gauge, the creep effect should be there in our gauge. Next is the temperature effect. This is the last effect. The change in temperature affect strain measurement. Okay, change in temperature affects strain measurement. How? There is a change in gauge resistance and differential expansion of gauge element result in tension or compression. Okay, tension or compression depending upon the value of temperature, that is either increasing or decreasing. It can be avoided by correct selection of the gauge material. So while selecting the gauge material, we need to mention, or we need to take in account, take in mind that temperature effect are there in our strain gauge. So if temperature is going to be increased, then the length of the gauge is also going to be increased, and there are also creep that is going to be introduced in our strain gauge. And if the temperature is going to be decreased, the length of the gauge is going to be reduced, right? So same effect are going to be observed. So lots of amount of error are going to be introduced in our measurement. If short leads of wire having opposite temperature coefficient are connected in series with the gauge, then the temperature effect can be reduced, because if our material or our strain gauge material is the positive temperature coefficient, we can directly connect it with negative temperature coefficient and we can eliminate both the effect, right? Practically, the error are eliminated by connecting the gauge in differential pair in Wheatstone bridge circuit by placing temperature composition element circuit. Okay, what is Wheatstone bridge circuit? We are going to study it in the next chapter, or we can say next lecture. But right now, to eliminate error, we can connect the differential gauge in Wheatstone bridge arrangement. So with the help of Wheatstone bridge, we can eliminate the temperature coefficient effect, and which is we are going to study in the next video lecture. So these are some important GTU questions that are asked in your examination and very important with respect to your examination. So please note this down, which we are already covered in this video session. And if you have any kind of query regarding this session, so please ask me inside of the comment section. Thank you.